All right, problem number 81 says, let me go ahead and write that down so we remember the number. The perimeter of a certain basketball court, I'm going to write down perimeter, is equal to 266 feet. Okay, and its length is, so remember is means equal, length is equal to 35 feet more than its width. So if I have the width, I could just add 35 to it. Okay. Remember, more than tells me a good variable to choose, and usually we choose what comes after the more than, and so width comes after the more than, so it's a great variable to choose. Now the thing about it is that the length is width plus 35. We could just call the width W, and that way I've got one variable now. The thing about perimeter, they want to know the dimensions of the court, so they want to know what the length and the width are. If you got a rectangular court, remember that the perimeter of a rectangle, you could write it as 2 times the length plus 2 times width. They want to know what that is. Oh, no, we know what it is. It's 266 feet. Okay. Now the thing about it is, I've got the 2 width, 2 times W. I could write 2L, but it'd be better if I could just use one variable. So if I read and have written that the length is width plus 35, I can take that and use that for my length. And now all I got to do to solve this is just simplify this and just kind of keep on solving it. I'll have to distribute on the second side. I'll get 2W plus 2 times 35 is 70 plus 2W. Well, on the right-hand side, 2W and 2W make 4W plus 70. And if I want to solve for W, I'll subtract 70 from both sides first, because that's what we do when we do PEMDAS backwards. That'd be 196 is equal to 4W. And if I divide both sides by 4, W is 196 divided by 4. Let me come over here and do that since I don't have a calculator on me. It's 16. It's a 4 up there. 36. So it's 49. The width is 49. So now if my width is 49, that's one of the dimensions, all I need now is to find the length. And I'll put my answer up here when I get it. Well, if you look at up there, your length is just your width plus 35. So since the width is 49, I would just say 49 plus 35. And when you add that together, you get 84. Now we could check this to see if it actually works. Let's see, 2 times 49, remember, because it's 2 times the length and 2 times the width, so I just basically double each dimension and add them together. 2 times 49 would be 98, and 2 times 84 would be 168, and if we did it right, it should add up to 266, and it did, so it worked. Okay. All right, then we're going to do number 82 now, and that'll be all that's on this video. At 10:30 a.m., 2 planes leave Houston. So here's Houston. One's flying east, so it's going this way, at 560 kilometers per hour. And the other one is flying west, so it's going the opposite direction, and it's going 640 kilometers per hour. At what time, it says, will they be 2,100 kilometers apart? So what's the distance apart that they're going to be? They want to know when is the distance that they're apart, 2,100 kilometers. Okay, now the thing about it is, I need to, basically, if you think about what's going on here, I'll call the planes east and west, just by what they're, what direction they're flying. So if I have the distance from the east plane, and I add in the distance from the westbound plane, they want to know when does that distance equal 2,100 kilometers. So there's the kind of overarching idea going on here. Now the thing about it is, in order to find the distance of each one, I would have to know the time that they traveled. So the distance for the eastbound plane, and again, remember we know this little equation, distance equal rate times time. The distance for the eastbound plane would be its rate, which is 560, times the time t, okay? Now, the thing about the westbound plane is it's flown the same amount of time. They take off at exactly the same moment. So its distance would be its rate times its time, and it's flown the same amount of time. So its rate is 640 kilometers per hour times the amount of time, because they both are flying the same amount of time. So if you do it this way, you actually have just one variable. And we could say, okay, the eastbound plane has a distance of 560 t, and the westbound plane has a distance of 640 t, and it's equal to 2100. And this is going to be pretty easy to solve, because all we have to do is add these two numbers together. 0 and 0 make 0, 6 and 4 make 10, put down a 0, carry your 1, 11 and 1 make 12. So we have 1200 t is equal to 2100. And in order to get t by itself, we would divide both sides by 1200. And we'd get t is, okay, it's going to be, I could cut the two zeros off, right, on both of them and just say this is the same thing as 12 into 21. And so since I don't have a calculator, I'll just do this real quick. It's going to be 9, put a 0 down, 12 goes into 90, 8 would be 96, so we'd have to bump it down to 7, that would be 84. And then I'd have a 6, I can add another 0 and carry it down. 12 goes into 65 times. So the time, which we're measuring in hours because our rate was in kilometers per hour, is 1.75 hours. Okay, so now probably though, the book's going to ask you to give it in hours and minutes, okay? So here's the thing, we know that's 1 hour and part of another hour. It's 0.75 of another hour. So isn't 0.75 3/4? So it's basically 1 3/4 hours, right? Okay, so we know it's 1 hour, but how many minutes is it? Well, I could say, well, what is 3/4? There's 60 minutes in an hour. So what's 3/4 of 60? 4 goes into 4 once. It goes into 60 15 times. 3 times 50 is 45 minutes. So if the book gives it in hours and minutes, they're going to say 1 hour 45 minutes. And if they do decimal hours, they'll say 1.75 hours. Who knows what they'll do? I haven't looked, and a lot of times I don't even check it when I do the videos because I'm just, usually I can make mistakes, so let me know if you ever find one. I would want to know that.